Let's look at one application of logarithmic and exponential equations using compound interest. So in this example here, we want to see how long it's going to take for an investment of $1,000 to triple in value if the interest rate is 7.5% per year and it's going to be compounded quarterly. First, we need to determine which equation we're going to be using. Because it tells us we're compounding our principal quarterly, what we're going to be using then is not continuously compounded interest, but compound interest with a finite number of compounded periods. The equation then is going to be given by A of t is equal to P of 1 plus R divided by N of N raised to the t. Our initial investment is $1,000, so our P is 1,000, and we're looking at tripling our principal income. So our A of t is going to be equal to 3,000. Our interest rate R is equal to 7.5%, and our N is equal to 4. Let's plug all this information in on the next page. Plugging in, we get 3,000 is equal to 1,000 times 1 plus 0.075 divided by 4 raised to the 4 times t. Let's simplify inside of this, the base of this exponent. Using a calculator, we see that this is going to be the same thing as 1.01875 raised to the 4 t. But we have 3,000 still on the left and 1,000 on the right. Dividing both sides by 1,000, we get that 3 is going to be equal to 1.01875 raised to the 4t. Let's go ahead and solve for t now. Taking the natural log of both sides, we'll get the natural log of 3 is equal to the natural log of 1.01875 raised to the 4t. Using the properties of logs, we can go ahead and bring the exponent down in front of our log. And we're going to get an ln of 3 is equal to 4t times the natural log of 1.01875. Dividing both sides now by 4 and the natural log of our decimal number, we get that t is going to be equal to the natural log of 3 divided by 4 times the natural log of 1.01875. Plugging this into a calculator, what we're going to get out is that this is approximately equal to 14.79 years. Let's look at one more application example. Here we'll be looking at radioactive decay. And we're given a 15-gram sample of radioactive iodine decays in such a way that the mass remaining after t days is given by the following equation. After how many days is there only 5 grams remaining? We're going to go ahead and assume that t is measured in days. So we're given 15 grams is our initial amount of iodine. And we want to see how many days it takes so that we only have 5 grams remaining. This means that we can rewrite our equation as 5 is equal to 15 e raised to the negative 0.087 t. Then we just want to go ahead and solve for t here. So let's go ahead and start a new page. And go ahead and divide both sides by 15. We'll get 1 divided by 3 is equal to e raised to the negative 0.087 t. Go ahead, take the natural log of both sides. The left-hand side remains ln of 1 divided by 3. The right-hand side is then equal to a negative 0.087 t. Then t is going to be equal to the natural log of 1 divided by 3 divided by a negative 0.087. We can remove the negative sign if we want, and the way we can do this is the natural log of 1 over 3 is equivalent to the natural log of 3 raised to the negative 1 divided by negative 0.087. Pulling our negative exponent out, we'll get the natural log of 3 with the negative in front divided by the negative 0.087, which is then equal to the natural log of 3 divided by 0.087. Plugging this into a calculator, we're going to get that this is approximately then equal to about 12.63 days.